Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
What's up, everybody? Nick, when it's my turn, can you just say my name? I can hear you. Okay. Cool, dude. What's up, Sensation?
I am so very nearly burnt out.
I'm fucking burnt out. I got on a plane I had to wake up at 4:30 Chicago time, so it was really like 2:30 California time. And then I landed here in LA at 9 a.m. I rushed home, prepped a lecture. Then I had to teach, and then I'm here. So I'm very burnt out right now.
Indeed.
Indeed.
Definitely more burnt out than me.
Well, it's okay. It's not a contest, right? It's not a burnout contest.
Yes, we're not driving.
Oh yeah, burnouts. Oh, that's a thing. That's a thing. Let me see. Do I have to force my horizontal to go live? I don't think I need to. Oh, I do. There you go. Okay.
You're gonna hate me for this one.
What's up? Your video's kind of choppy. It's not coming in like very well.
It's not me.
Do you see that on your side? No, it looks fine on your side. Oh, yeah, no, it's like stuttering. Yeah, try turning it on again. Aleph says it looks choppy too. That's on you, buddy.
Hang on.
What's up, Recky?
How about now?
Ooh, yeah, much better. Ooh, yeah, you're fluid. You look like one of those like peacock things that goes around like. Oh, why is none of my Sammy stuff working? Oh, I didn't turn on the SCP redemption. That's why.
Okay, here's what you're gonna hate me about.
What are you gonna hit me about? What's up?
Square root of x
Square root of x.
X cubed square root. Shit.
X squared of x. Square root of x times x squared square root of x.
Square root of x times square root of x cubed, but then the cube might be inside the square root.
Oh, okay. You know, it actually doesn't matter where it is. Doesn't matter if it's inside or outside. What's up, Sibley? Good to see you. So you're saying like this times this?
Yes, and then I've just written square root of x to the 4
It is square root of x to the fourth, which
Then
is
I've
equal to,
written
I guess,
x
x squared. Yeah, I think I agree with
Yeah.
that. Fan of that. That tracks.
Okay, I guess I didn't get it wrong.
Well, so there's actually
This
kind
is
of a
big
cool thing
question
here.
mark.
So you can actually put the exponent all the way out if you want. Oh, is this, what is this? Oh, there you go. Oh, this was your work. What were you prepping for? Is this for one of your tests or something?
I don't know, I just picked a piece of paper.
Oh, okay.
I was like, why is there a question mark? And then I was looking and I was like, I've not solved it.
Yeah, no. I mean, so it actually doesn't matter if the the power is on the outside or on the inside. I guess it kind of enforces like some positive negative stuff, but it really doesn't. Yeah, unless it's imaginary, but who cares?
Square root of x and square root of x is x.
It's technically like the absolute value of x, I think. Square root of x times the square root of x, because you kind of enforce that these have to be positive, right? You can't take the square root of a negative number, right? But
I still haven't taught myself to do that properly. I still to this day remind myself that if it's a square root, it can have a positive or negative integer.
yeah, no. So square roots can only return. I mean, square roots can only return positive numbers unless you return, yeah, imaginaries. But then we start dealing with like numbers in other systems that most kids in middle school and high school don't really deal with.
I just mean like square root of 4 is plus or minus 2.
Oh, interesting. No, so yeah, the square root of 4 is technically 2 because we only consider the positive root whenever we do square roots. I know what you're talking about, right? Because technically,
Okay, now I'm convinced.
yeah, I know. No, I remember doing this when I was like helping out some like middle school kids with their homework. But yeah,
Oh, yeah, don't make me feel too bad.
no. I mean, I get this wrong too because I see this and I think, oh, this is plus or minus 2, right? Because negative 2
Right.
squared equals positive 2 squared equals 4, right? And you think, oh, well, the square root, right? Doesn't that mean negative 2 equals the square root of 4? And it's just like, there's some math argument for like why we only consider the positive root when we do it. I'll let someone else who's smarter in math refer to it, but it's
hang on, so 2 implicitly, or just, you know.
yeah. We just say it's
I don't
just
know.
we just say it's positive 2. The only time
Yeah,
you do
I
the
just mean,
plus minus thing is when you're solving for a variable. If you're solving for a
Okay.
variable, you take the square root, then you need to like consider the plus and minus. So if you say, for instance, like x squared equals 9, and you want to get rid of the x squared by taking the square root, here you have to say, oh, x is equal to plus or minus 3. Technically.
Okay.
Okay? But if you just say the square root of 9 on its own, that's just equal to 3. You don't say plus or minus 3.
Okay, that's where I was getting confused.
It's just because
Right,
of
now-
this.
Yeah, now I get it.
Yeah. There is some math argument. Yeah, there is. Let me see. Meowcat says, can we talk about questions 10 and 12 on the capacitance and dielectrics somewhere? Yeah, we can totally do that. Let's get into it.
Just after this last one, then.
Okay. What's the last one you got? Let me pull up the Kudu stuff. Up.
X to the half.
Yeah.
X to the half power times x to the 3/2 power.
Oh, you just add the powers in that case. So that's just equal to x squared. Because it's the same thing as x to the 1 plus 3/2, which is equal to x to the 4/2, which is equal to x squared.
Yeah, that's what I got. Okay.
Yeah. Those are some good exponent rules. Those are pretty dope. Good to know. I mean, a lot of people forget them, honestly.
I did.
It happens. Let me see. Questions 10 and 12 on the capacitance homework. Yeah, so I had lecture today. Again, I was spaced out, man. I was so tired. Because I was on a 5-hour flight from Chicago, which is Spirit, the absolute worst. Literally, it's worse than
Okay.
Ryanair. It's so bad. Yeah. But
Nothing's worse than Ryanair.
did you see they're doing standing only for Ryanair now? They're gonna do like standing
Are they,
only
are they
seats.
actually doing that now?
I saw that.
They've been talking about
you
it for
could
10
you could
years.
hold on to like a fucking bus pole.
The plane will crash and everybody will die.
Yeah, bro, I'm starting to, dude, I usually never get nervous when flying, but recently I kind of have been just because I don't know, man, dude. There's too much weird shit in the news that just like keeps happening, and I'm like, excuse me, are accidents up, or are we just more attuned to them right now? Like,
The more people there are, the more flights there are. The more flights there are, the more likely there is to be a crash.
Yeah, more likely, I guess, you are to see one, like in a news article. I don't know. I guess there's just been like a lot of close calls. Like that one plane just like fucking went down in DC, right? That hit the helicopter. And then there's another one recently. Like some Delta pilot apparently had a near miss with a B-52. It's a massive plane.
Yes, it is.
Like, how do you not see a B-52?
How do you nearly crash into a flying building?
Yeah. Yeah, and Sib says, did you see the poor man who died from wearing a chain and walking into an MRI machine? I heard about that one.
Right.
Yeah, also, yeah, someone, yeah,
Right,
MRIs have very strong magnetic fields, you know, yeah. I mean, there's a... yeah.
If someone's going to die from that, let them.
Yeah, that's Sensei's gonna say that's kind of natural selection, unfortunately. But also, like, no one should have let him next to that. Like, they say in so many warnings, like, do not bring metal next to an MRI. It generates, like, extremely strong magnetic fields. It's like Magneto. Did no one watch X-Men? No? I don't know. Yeah. Okay, two infinitely long straight wires have a cross-sectional radii A. The distance between their axes is B. What is the capacitance per unit length of the system, assuming B is much greater than A? Cool. I don't know. Oh, we'll try to figure it out, I guess. B is much greater than A. What's up?
I've only just noticed TPG's comment.
What? Which? Oh, the argument.
For future reference, don't get arguments confused with oh my god.
Parameters.
Even I've forgotten now.
Functions.
Yeah, don't get arguments confused with parameters.
There you go. Args and params. Okay, so I think we have like... Oh, wait, sorry, no. They have the same radius, right? They're located at distance B from each other. Yeah, I need to draw some things. I like drawing. Apparently I didn't put this anywhere close to where it should have been, though. Okay, whatever. We're just going to take a second here. Okay, cool. No! Okay. And the distance between their axes is B. Length is B. And then they have... What is the capacitance per unit length? So... again, I'm not even looking at anything. I'm just doing this off the top of my head. Q equals VC. So capacitance is equal to Q over V. And then if it's capacitance per unit length, right, we divide by L. This is Q over L. Q over L is usually like a lambda, right? This is charge per unit length. So we can say C over L is equal to like lambda V. All right, and let me see what the answer choice is. What do I get to play with? Oh, nothing. Oh, okay, so lambda's got to go away somehow. Okay. Thank you. I will drink some water. Bless you, Sam.
It's pronounced water.
Water. Okay. So, I need to figure out the potential between these two. Okay. I don't think we... Are we going to deal with A? Is A in my answer? A is my answer. Ew. Okay. I see. We probably got to integrate like E.dl or something. Okay. They're wires. So if they're wires and they have charge on them, charge is always going to be congregating on the outside. Okay? We cool with that so far? So you always got charge on the outside. I think I see what's going to happen. I wonder if I want to do this with the infinite... No, let's do it with Gauss's law. Screw it. I'm going to do it with Gauss's law. I'm going to figure out what the E field here is. Like right here. I'm going to figure out the E field. And then from that, I think I'm going to figure out what the potential is by doing integral of E dot dl. From like, probably like from here to here or something. And then from that, I can then probably figure out what C over L is, because I'll have this, and hopefully this will have a lambda in it, I think. I'm spitballing. Okay. All right, so let's say for an infinite line of charge, right, for the cylinder thing, we know that E times 2 pi RL is equal to Q enclosed, which Q enclosed, that case, is like lambda times L over epsilon naught. And so I get that E is equal to, L's are going to cancel, 1 over 2 pi epsilon naught, and then it's going to be 1 over R. This is the E field due to a line of charge. And if we're looking like somewhere outside it, okay. So then the potential is defined as integrating the E field from some location to some other location. And I think I'm going to do that from... Let me think. I'm going to do that from A to B. Yeah. Because there is no E field inside here. Right? If this is a conductor. I say E equals 0 here. Right? So I'm just going to take the integral from here to here. And I'm going to say that changed potential. And then I'm probably going to double it because there's 2 of them. So, yeah. Yeah. Okay, so let's integrate from A to B, and then I think it's negative, right? A to B, and then I think there's a minus dot dl. So this is equal to the integral from A to B negative, and then this is going to be 1 over 2 pi epsilon naught 1 over r, and then dl in this case is going to be dr, because we're traveling this way. Let me just see if I get the right answer, and then I can go back through and kind of explain what's going on. So I think this is where we're measuring E field. And then I'm measuring R from here, I guess. Okay. This is going to be ln of R. So I'm going to get negative 1 over 2 pi epsilon naught. And then that's going to be ln of 1 over B minus ln of 1 over A. Sorry. No, ln of B minus ln of A. Not 1 over B, sorry. ln of B minus ln of A. And there's a minus sign still up front. So this becomes A minus B, and then A minus B is A divided by B. So that's 1 over 2 pi epsilon naught. And then we're going to say ln A over B. And then... Okay, cool. That's the potential due to one line of charge. Wait, there needs to be a lambda in there somewhere. Yeah, we fucked up. Sorry, there's still a lambda here. Sorry, still a lambda. Yeah, okay. So, we still got a lambda. So that's E field per unit length. Okay. And then I think I want to double this because this is the potential just due to one straight wire. Another straight wire would add up and then give another potential. Assuming that the wires are carrying like the same charge. Oh, did we say they're identical at all? No, it said infinitely long straight wires. I think you assume that the wires are the same. Anyways, okay, so... Or that, like, one has positive charge on it, one has negative. So I think there's another E field. I think you get twice. So I think you multiply this by 2. So then you have V is equal to pi over... Or sorry, lambda, pi epsilon naught, ln of A over B. This is like 2 wires. And then... Oh, C over L is lambda over V. So that's going to be lambda over pi epsilon. F equals Q. What's up, Dr. L? Unfortunately, not in this class. That's the next class for them. Oh, lambdas cancel. Okay, so I get pi epsilon naught over ln A over B is capacitance per unit length. Is that the correct answer? Pi epsilon naught ln A over B. They have ln of B over A. Uh-oh. What did I do wrong? Not ln of A over B. Damn. Maybe I'm not supposed to go from A to B. Yeah, I'm supposed to go from B to A. Oh, wait a minute. B is not the halfway point. I'm so dumb. B's way over here. Right? But then I guess, Okay. Let me see. Okay. Close. I have a minus sign. I have a minus sign missing somewhere. Let me see if I can get a little ChatGPT inspiration from this one. Just see where I'm wrong. Solve this. Go find me something. Comes from simplifying arc Kosh. Excuse me? Dude, what? Okay, wait. So I ask, where'd that first result come from? Like, cool, Art Kosh, but where the hell did you get Art Kosh from? We haven't dealt with any hyperbolic trig functions in this class. It comes straight out of the exact solution of Laplace's equation for 2 parallel cylinders. Most cleanly done by a conformal map into elliptical coordinates. Don't really know. Nope. What the hell are they doing here? Okay. Let's see if this is in your book somewhere. Or in the textbook. It needs to be. Because where did this number come from, dude? What? Okay, here we go. Oh, V, they don't have a... I thought potential was equal to negative E dot dl. Right? I'm not crazy, am I? Yeah. Yeah, what? Change of potential is negative E dot dr from A to B. Okay, so I think they want us to take a similar intuition from what happens with the spherical capacitor case they talk about. So here we're doing like two cylindrical things next to each other. And so yeah, cool. I calculate the electric field in between, right? And here you get kq over r squared. For the cylindrical thing, you get 2 lambda over r. That's what we got. Integrate along the radial path between the shells. So this is going from R1 to R2. Here we ignore the minus sign. That's because we just want the absolute value of the potential difference, and integrating over the path from high to low would otherwise give us a negative value. Oh, okay, cool. Alright, and then they just do C equals Q over V. Okay. Okay. I don't really see where the cost comes in. But I guess this, right? Infinite line of charge, and then we get rid of this minus sign. Because we say, we just want absolute value of V. Because, yeah, you are going from, like, higher potential down to lower potential. I see. Okay. So if you get rid of that, then this is ln of b over a. But then why do we multiply it by 2 again? Right? Why is there a 2? Here, voltage can't be 0 to infinity because it's 2 infinite cylinders, right? I don't know about saying there are 2 different Ks.
Two different Ks. One's potassium, the other one's ketamine.
Don't forget your vitamin K.
Ketamine. Just say nay.
We have 2, and then K is equal to 2 pi. Sorry, one second. Let me see. Let me get the answer choices real quick for this. I think my tiredness is just setting in. Yeah, K is 4 pi. Okay. Yeah, we haven't used anything with K yet, Sibley. So, when we derive this, yeah, this is the same thing as 2K lambda over R. And this is the E field at a radius R for a cylinder. I agree with that. I'm leaving the pi epsilon naughts because eventually I want my final answer here to, I think, have just pi's and epsilon naughts in it. Because this is the correct answer on the homework. They say it's this, which is very I mean, it is close to what we got. I'm just curious where we just multiply by a factor of 2. Oh, you're okay. Let me tell, like, why are they using these ADAs and stuff, dude? Chill. Here, I'm gonna say, do it in cylindrical. Or, you know, this may be on the web somewhere. Let's just go find it. What was it? Capacitance of 2 infinite wires. Yeah, here we go. All right, let's see where they got it from.
Cinema Line, FX2.
I thought it started at A and it went to D. So let's see what this Dr. Ben Yelverton does. So, yeah, I agree with this. C is eventually going to be lambda over V. We're only going to consider one of them to be positive. Yeah, so from each wire, 2 pi RE. Oh, I see. I see. The electric fields are adding, Dr. L. Do you see this? I see. A to D minus A. Okay. D minus R. Okay. Yes, it is from one surface to the other, right? And then they're saying the electric field from the other one is D minus R. Uh-huh. I see. That's cute. Wow, this is actually really cool, this derivation. Okay. Yeah, they did. Yeah, they used it in the center one of the cylinders. Okay. Notice how there was no Kosh thing here. Yeah. Yeah, wait, what? Alright, here. Yeah, okay, just hang with me. I'm just gonna redo it. We were along the right lines, but yeah, let me just read. Do you think something on that may end up in an exam? If I do it during office hours, you may have noticed it usually does come up on an exam. Maybe. Okay. Yes, but yeah, if you pay attention during office hours, there are benefits to that. 1 second, move this out of the way.
Focus. Do cocaine.
Focus flakes. I didn't have any coffee this morning, man. Speaking of uppers. Okay. Okay. Let's define a coordinate system here. I'm just gonna define a coordinate system real quick. And actually, you know, I wanted to go. I'm gonna have to go from this one because otherwise, like, things aren't positive, and it starts making me upset. So, here's what we're gonna do. We're gonna say, in order for there to be capacitance, right, there needs to be some positive charge enclosed on one side, and then there's gonna be some negative charge enclosed on the other side. So actually, let me switch the colors of these. So you have positive charge on one of the wires. Alright, so this is positive lambda. And then you have negative charge on another side. We're going to call this x equals 0. Okay. And then we know the distance from here all the way to here is equal to b. Okay? Okay. That's how I'm going to set this up. And then I'm going to say this has negative lambda. Okay. I'm trying to figure out capacitance per unit length. Okay. So let's just like write it. So I want capacitance per unit length. But Q equals VC. So C over L is equal to Q over L divided by V. So all I did was I moved that over and then I divided both sides by L. And then this thing here, this is equal to lambda. What's up, 1K? Okay. So really what I'm trying to figure out over V. So and this is the potential difference. So this is really delta V. So this is delta V between the cylinders. Okay. Now, this positively charged wire is going to create an E field in this direction. Okay. And this negative charge here, by the same token, is going to pull in an E field towards it. Okay. Such that E total at any position X, which is really R, like away from here, okay, is going to be equal to E plus plus E minus. The superposition principle, exactly. Yeah, nature didn't have to be this beautiful, but she did, dude. Yeah, she surprises us sometimes. Pretty cool. Okay, so we know, right, that E for an infinite wire or infinite right? That's equal to 1 over 2 pi epsilon naught. And then it's going to be lambda over R. This is, we've derived this before. That came from Gauss's law doing this. E times 2 pi RL, that's the charge enclosed, is equal to lambda L charge enclosed over epsilon naught. So 2 pi RL is the surface. This is like the surface area of this thing. Yeah. So this is from Gauss. Okay. So then E positive, right, is equal to 1 over 2 pi epsilon naught lambda, okay, divided by X, right? If we're calling this X equals 0, the E field created by the positive charge here is just going to be over X. If we look at the E field created by the negative one, okay, that's 1 over 2 pi epsilon naught. There's technically a negative lambda here, but I'm just gonna make it positive because the E fields are gonna add. I don't want to keep like putting minus signs in places. But this is the difference though. Now, wherever you are, let's say you're located at some position out here, right? Let's say this is just X, okay? The distance to the negative wire is now going to be B minus X. Yeah, so this is going to be... What's up, Pink Rose? This is B minus X, okay? So if you're located at x equals a, right, that would make sense because b, no, sorry, you wouldn't be located at x equals a. You'd be located at b minus a. Maybe in a bit, Roman. I'm doing ENM right now. Okay. Let me make this a different color too, actually, sorry.
How about no?
No. I can help with some quantum. Okay, let's say this is b minus x. There's a link down there, Roman. You should be able to see it. It's very, very easy to find.
And if you can't find that, then you've got no chance at quantum physics.
Yeah, yeah. Yeah, then when we have a problem. Okay.
Unless you're blind and have no fingers.
Okay. Does this make sense so far? Meowcat. Is Meowcat who asked this question first? Meowcat. Does this make sense so far? How I'm defining the electric field being created from each wire? Okay, cool. All right. Okay, so then E tote as a function of x is equal to this plus this. Someone send him the link. What do you mean there is no link? I'm pretty sure there's a link. Doesn't it just say like actualdiscord.com/submit? Or it depends which YouTube stream you're on. Oh, yeah, no. Well, actually, no, you should see it anyways.
The Discord link's right there.
It's on the ticker bar, bro. Do you see the ticker bar down there that says need help with a homework question? Go to www.actualdiscord.com/submit.
Or discord.gg/actualedu.
Yeah. What? I mean, no, it's a legitimate question. Like, I always want things to be like really obvious. If it's not obvious, then I guess I need to make it more obvious. Yeah, there's no link in the description. I probably should do that. Okay. I'll think about that, Roman. I have the link like in the video feed, but you're right. I don't have it in the description. Okay. Fuck am I doing? Okay. Now I need to calculate delta V between the plates. Or between the wires. Yeah, no, it's good to know. Good to know, Roman. I like to know what people do, so I can fix that. Okay, so we're going to integrate then from starting at A. If I want to find the delta V, right, in between these two things, I need to figure out what the integral of the electric field is from here to here. Okay? So we're going to start at A. And we're going to go out to B minus A. Right? So we're starting here at x equals A. And then we're going like almost all the way out to B. But B minus A will bring us to this edge right here. And then that's of all this. And this is dx. Okay. So now you can pull the 1 over 2 pi epsilon naught out. And the lambda too. All right, so this is lambda over 2 pi epsilon naught. Integral from A to B of 1 over x. Plus integral from A to B. And whatever, there's a parentheses here. And then this is 1 over B minus x. Okay, cool. And sorry, it's A to B minus A. Not A to B. All right. This is now lambda over 2 pi epsilon naught. That's going to be ln of x evaluated from A to B. And then this is going to be negative ln of B minus x from A. I keep forgetting. A to B minus A. Yeah. And that's because there's a chain rule or like a U sub on... and this is also dx, sorry. Okay. Okay. Lambda over 2 pi epsilon naught. And then you have ln of B minus A divided by A, because that's what happens when you subtract the two logs. And then we're going to do minus, and then this is ln of b minus b minus a. God, that's ugly. Over b minus a. Okay. So wait, now these are all going to like super do things, right? Because now I have like, I can do super log combination thingies here, right? Because now I have two ln's minusing each other, which means it's the same thing as them like reciprocal multiplying on the inside. So this is ln of b minus a over a times b minus a, right? Yeah. Over, and then that's b minus b, so it's just over a. Okay. Cool. Lambda over 2 pi epsilon naught ln of b minus a squared over a squared. So let's just expand that, right? So that's b squared minus 2ab plus a squared all over a squared. Should have taken 2 in the front. Where was I going to take 2 in the front from? Oh. Thank you. No, Aleph is right. Much better, Aleph. Aleph. Yes. Yes, you're right about this. Okay. Sorry. I'm explaining every step because I hate when... I don't know. B minus A over A. Good. Okay. That's all squared. And now you can bring the 2 out front. So now it's 2 lambda. Oh, so it's just lambda over pi epsilon naught ln of b minus a over a. Okay, very cool. And then I think we said b is much bigger than a. So if b is much bigger than a, then b minus a is basically just b. Because subtracting something insignificant to b is the same thing as just leaving it as b. Oh, I see. So now you get pi epsilon naught ln. So this like kind of goes away. You just get ln of b over a. Oh, beautiful. Which, okay. And then c. So this is delta v. Q. So c equals lambda L over delta v. This is going to be equal to pi epsilon naught. The lambdas will cancel. You're going to get, okay, so pi epsilon naught L over the ln of b over b over a. So then move the L over, and now you get c over L is equal to pi epsilon naught ln of b over a. And that's the correct answer from here. Wow. Nice. Okay. Does that make sense there, Meowcat? What a pain in the ass this one is.
I found a great way to mess with the new students coming up in September.
What are you gonna do with them? Meowcat, I'll explain in a second.
I'm gonna drop a 3.5 floppy disk on everyone's in front of everyone and say this is 1.44 megabytes. Discuss.
Discuss. No, you gotta get the big ones. You know, like the 5-inch floppies. You know what I'm talking about? 5
1/4.
5 1/4. How much could you store on those?
I can't remember. But that was older technology, so half.
Yeah. Yeah. Meowcat says, can you explain why we don't have a negative lambda on the second wire? Yeah, sure. I got rid of the negative lambda because I know that the electric fields have to add here, right? If I put a minus here, now they're going to like subtract from each other. They should be adding. I think the minus comes from So let's remember this is r vector r hat, right? And so technically for this one, like r hat points in this direction for the negative one, right? But I know the electric field needs to point inwards. So it's like I'm putting a negative on my r almost, right? Does that make sense? Like b minus x is the same thing as negative r for the second one. So if I do yeah, okay, good. Yeah. But the hand wavy way to do it, meow cow, is just to be like, well, I need these electric fields to add, so just fucking make it positive. Quantum equals HF, yes. That's all you need. I do too, Aleph, yeah. I mean, that's a lot of physics. A lot of physics is being like, well, intuitively they should add. But it is cool to then go into like the proper math and realize like, oh, okay, I get it. It's because my r hat points in this direction for this one, but r hat points in this direction for this one. So technically when you're calculating Gauss's law with the electric field, it's going to be flipped. Because the r1 hat is negative r2 hat kind of thing. Okay, cool. Alright, I hope that makes like some sense. I learned a lot of stuff on that one. Theta vector is not the same. Yeah. Okay, you said also question 12? Let me see what we got on question 12. Oh, this one's a mess. I feel like... I think Albert answered this one. Let me see what Albert wrote, just so I don't have to reinvent the wheel. Albert Einstein? No, Albert's our TA. Oh, okay. I see what we're gonna do. Yeah, the shortcut. Okay. Okay. Here, yeah, he calls it like nudging. It's kind of funny how this works. But imagine that, like, I want to think how I want to define this for you guys. Okay. Position A, position B. Let's assume this is positive and this is negative, and then let me just like kind of write what the charges are, right? This would have to be positive. And then I guess this is negative, but this is also negative. So wait a minute, is this positive? And this is negative. Oh, but look, this is a positive side connected here. This is a negative side connected here. Fascinating. No, let me not do that. Okay. Let me try to draw it this way. Let's say this is A. Okay, I know A has to connect down to a capacitor here. C1. And then on the other side of C1, there's like this, but then this also connects back to this. It's a C2. Oh, wait a minute. this is here. Oh, this is hard to picture. I'm not going to do this to you on a test. If I can't see it, like what? Oh, wait. I'm missing capacitors. Wait. Which question was this? Oh, I'm thinking of a different one. Sorry, I was thinking about a different one. Okay. What's up, Sib?
Hey, Dr. G, could you quickly explain what those black dots are? Like, I think
Oh, they're just
Albert was
connection
saying-
points. They're just connection points. You talking about these?
Yeah, he was saying like you could add more wire or whatever. That's what the part I didn't understand what he was talking about. Like, is that actually physically blocking C1 from connecting to C2? Because that's why it looks like.
Oh, no. Oh, they
series-
connect. No, these definitely connect. The issue is that like this side is also technically connecting over here as well. Because so anytime something like goes through like wire, it connects with it. So, you want to say something, Aleph? Yeah, sure.
Q.
Yeah, if we want to think about it in terms of voltages, does that mean these two things have to have the same voltage as this? I'm not sure. Voltage across a wire is the same? Well, yes. Oh, I see. Yes. Okay. All right. I think I see this now. Okay. They want the voltage difference. Well, they want the capacitance between A and B. So, I think eventually we're gonna think about what the voltage is and what the charge is, I guess, on them. So let's call this like V plus, and then this is V minus. Then anywhere along this wire, if there's nothing else on it, that must also be at V plus. So that tells me right away that this is at V plus. So this is also at V plus, right? And then right before this wire, right before this plate, that's at V plus. That tells me this is at V minus. And then this is V minus. And then this is V minus. And this is V plus. Do you not want to be a speaker, Aleph? You don't have to be a speaker. I can move you back to the stage. Actually, I forgot how to do that. Oh, you're new to Discord? Okay, that's fine. Oh, yeah, okay, I think I see it. Okay, so wherever this thing is connecting to the plus, right, that's every bit of the capacitor is there, so watch. So, for C1, which, let me kind of like show, right? C1 looks like this, right? I'm going to pull it down and like rotate it. Like rotate it like this way. Okay, so let me like try to draw. So
Advice.
I had it like this. What's up?
There was a piece of software. I forgot exactly what it was called, but that's the point of this. It was like a circuit diagram drawing software.
Yes.
that
You can
you
move things
could
around.
Test the circuits on.
Hello.
Yeah. What's up, Ethan? So this comes up. Okay, right? So this is all connected right here to A, okay? But the positive side from this is also like lifting up these two. So it's also connected to V plus of C2, and it's connected to V plus of C3. And then look, the minus sign and the minus sign from this one are now connected to each other. So that means this and this are connected to each other, right? That's the minus sign of C. So that's like V minus from this side. And then for C3, right, these two minus signs are also connected to this minus sign. Ah. Okay. And then these things are all connected to B. You see how B connects to this side, it connects to this side, and it connects to this side? And then if I were to like pull this side up, I'd be like dangling this positive and then these two positives. So now you literally just have 3 capacitors in parallel. And so then C total equals C1 plus C2 plus C3. Yeah, that's cool. Do you see that? Do you see why that is, Meerkat? Yeah, say that again. Okay. I'm going to mark this point here as positive, okay? And anywhere along this line, as long as it doesn't like go across a component, it's also going to be positive. That means this is positive, right? Straight there is positive. Keeps coming this way. That means this is positive. That means this is positive. Okay? If I come from point B here, which I'm going to call like the negative side of potential that I'm measuring, then that's going to come here, make this negative. It's going to come up here and it's going to split so that this is negative and this is negative. Okay? Now what I see, right, is that A is connected to the positive end of C1. It's connected to the positive end of C2. And it's also connected to the positive end of C3. Right? With nothing in between. Right? Wire does not count as in between. As long as it's like going to things, you can always like shorten the wire. So that's A. And then B, which is negative, okay, that connects to C3, and then it splits and also connects to C1 and C2. So that's going to connect to C3 on the negative side, and then it's also going to connect and split to C2 and C1. And this is negative side, okay? So now there are 3 things that are in parallel, right? Because the minus sign of all these things are connected to the same point, and the positive signs are connected to all the same point. So then it's just 3 capacitors in parallel. So here, let me make graphs. You finally get it? Yeah. It's okay. So, again, anytime you have all the positive ends connected to a single point and all the negative ends connected to a single point, this is parallel. Yeah, you see it? Yeah. But anytime you have like positive to negative, positive to negative, positive to negative, that's series. Nice. Okay, cool. Yeah, this is tricky. That's a tricky one.
Yo ho ho, and a barrel of rum.
Yeah, I need a barrel of rum. I need a fucking gallon of rum at this point.
You want the good stuff? It is pronounced absinthe.
Absinthe. Yeah, the wormwood they only have in the real stuff, not the US doesn't have wormwood. You have to go over to like Eastern Europe to get the absinthe with the real stuff in it.
Wormwood, the hallucinogenic.
Yes, it is the green fairy, right?
I wouldn't know. We don't have that here either.
Definitely have it in Prague. I did like actual absinthe in Prague. Yeah.
Absinthe is good once. That's what I'm saying.
Yeah, and then it's like, no. It was some like pub crawl thing we had. That's what we did it at. Yeah.
What was the worst drink in the world? I think it was just called green.
Malort. It's called Malort. Malort is the worst drink in the world, dude. Okay, let me see. Mickey asks, so you had a question on, what was it? On the two metal balls. Oh, okay. I think this is the same strat as the last one we did. But now you just do it for spherical geometry, right? So, I think it's the same thing. Right? If this is A, and then this is B, call this one positive, call this one negative. Then E positive is equal to 1 over 4 pi epsilon naught, and then that's Q over R squared. And then E negative is equal to negative 1 over 4 pi epsilon naught negative Q over, and then instead of R squared, sorry, we're going to call this X equals 0. So sorry, this is going to be X squared. And then this one is going to be B minus X squared. So the minus signs will cancel out. And then you got to integrate it, I guess. So do the integral from A to B minus A. 1 over 4 pi epsilon naught. I guess there's a Q in there as well. And then it's 1 over X squared plus 1 over B minus X squared dx. Okay. So then that's negative 1 over X from A to B minus A plus positive 1 over b minus x. From a to b minus a. You get a negative from doing like, you know, u to the negative 2 integrated becomes 1 over negative 1 u to the negative 1, but then you have to take the derivative of what's inside, so that's why there's another positive that comes out. What's up, 1k? So then that's q over 4 pi epsilon naught. That's going to be negative... Or so I'll just switch the bounds. So that's 1 over a minus 1 over b minus a. And then this is plus 1 over a minus 1 over b minus a. Oh, fuck. I need a... I was hoping one of them would subtract. Damn. They do tell us B is much bigger than A, though. So if B is much bigger than A, then I don't think you worry about this. So then I think it's Q over 4 pi epsilon naught, and then it's going to be 2 over A minus 2 over B. So that's going to be Q over 2 pi epsilon naught 1 over A minus 1 over B. That's equal to delta V. But then C is equal to Q over delta V. So that's going to equal to 2 pi epsilon naught over 1 over A minus 1 over B. Is that the correct answer for 11? Let me see. No, they just say 2 pi epsilon naught A. Oh, okay. From this, if B is much bigger than A, then 1 over B is much smaller than 1 over A. So you can get rid of this as well. Fine. So now it's 2 pi epsilon naught A. Okay. Now you get the right answer. Aleph says, how much of a queue is left? How much money can you tutoring 2.5 to 3 hours a day? Honestly, I mean, it varies wildly. I'm getting paid $0 for this. This is just free. I mean, part of it's baked into my office hours I do anyways for UCLA, but depends on your clients. Depends where you tutor. Depends if you tutor in person. If I tutor someone in person around affluent areas in Los Angeles, you can get like 120 an hour, maybe like 140. If you're just trying to join the endless swarm horde of people online that tutor, you're probably gonna get like $10 an hour. Especially now with ChatGPT, it's just having an online tutor. I don't think is as valuable of a thing anymore. I would almost say you kind of have to teach for free online, because otherwise people can just get help somewhere else. Unless, again, you have like a reputation and like you're doing one-on-one stuff, but that takes a lot of time. And that's like a reputation you have to build too. Yeah. But you can try. There are various websites that have like online tutors and things. I think if you're not in the United States, you're going to run into a lot of problems with payments. Trying to do any sort of like payment processor if you live in like Bangladesh or something, just not going to work. You just won't get a bank account. It just won't let you. Okay, does this make sense to Mikyas? Mikyas. There's a couple like substitutions in here that are honestly like kind of ugly. Or not substitutions, a couple like approximations that I could see as being like hand wavy. Fedekai says, I'm a little bit confused over questions 8 through 10. Work and voltage, yeah. Well, electric field always points away from charge, okay? And then potential difference is always integrating between 2 points. And like depending which way you're going, that's sometimes in the direction of the electric field or not in the direction of the electric field. So here with 2 metal balls, which again we assume one is positive and one is negative, the E field is always pointing to the right. So when you're integrating E.dl, you're always kind of like adding electric field to get your potential. Technically, it's negative E.dl, and that would make sense because we're going from a positive to a negative, so we should be dropping potential. But when calculating capacitance, we only care about like the absolute value change in potential, because this Q is always kind of referred to as the positive charge on the plate. What about Canadian? I have no clue about Canadian. But probably also difficult because you're talking about US to... Just anything international with money just doesn't work. Unless you start finding clients that are going to pay you in Bitcoin. Which probably won't happen. Fedekai, also, when it comes to why we can approximate the voltage for a shell or a sphere as a point charge, what would be the difference between the inside and outside for conductors and insulators? So if you are outside of a shell or a sphere, measuring any sort of electric field outside of that, you can assume it's a point charge. When you're measuring the electric field inside of it, however, now it matters whether something's an insulator or a conductor. If something's a conductor, there is no electric field inside because there's no charge inside, right? All the charge is on the edge. So, yeah. If you have... Yeah, I know what CAD is. Oh. Sorry. You're saying, what about tutoring in CAD? Again, I don't really know. Maybe. You should just get a job just doing CAD. Yeah. So here, if you're measuring E or V, it's equal to the same as a point charge. Oh, okay. Yeah, so the positive and negative charge thing for potential energy, potential energy or potential. Again, all of it's very dependent on the situation. So what we've started moving into now is just measuring the potential difference between 2 points. When you start talking about the the potential energy of a system, now you're thinking about the change in potential between being all the way out at infinity and then being somewhere around your charges. Oh, okay. Work equals negative grad U. That's always from the force. It's from the field. The field is the external force. I don't think there everything we've been talking about so far has been forces due to fields, right? Like Coulomb forces. Okay. So, yeah. So, what are the external forces, though? Find me in the book, like, what it talks about. Like, are you saying, like, it would take a force in order to, like, arrange your charges in a certain way? That's correct. That's not, I don't think that's a negative. That's a positive. The potential energy of a system is equal to the amount of energy an external force would have to do to put the point charges together. That's the negative work that the electric field does when the chargers are being brought in. So if you have like a positive charge and another positive charge, and you want to know like the potential energy of the system, right? That's equal to the work done by, yeah, sure, an external force. Which you would have to do positive work, right? Because you're exerting a force that's in the same direction as the distance when you're pulling it from, again, zero potential, which is out at infinity, into here. Yes. Yeah. The work done by the field, well, think about it. So this thing has an E field that points in this direction, right? And so it has a related, like, F is equal to, like, QE that acts on this. But that force is opposite to the direction it's being pushed. So in this case, this will get you negative work. This will get you positive work. Yeah. Let me see. Conjure says, can you do some problems with double or triple integrals? Send me one. Just find one. I'll do it. Yeah, I think I did 10, Fedekai. I just did 10. Yeah, I literally just did 10. I could maybe do 8 for you. But yeah. 10 we did. That was with the capacitors. And then 11 I did as well. The key thing there, so with 10, when you're trying to find capacitance, you're trying to find the change in voltage between the two plates. So, hey, what's up? What's up? Good to see you, Obi. So you don't need to deal with taking something out from infinity and bringing it in somewhere. That's for like individual charges. Oh, you mean the homework today? Oh, what's the homework today? Send me a screenshot. That's always, yeah. Don't have me like hunting through which homework it is. Just send me a screenshot. I'll do it. Good to see you, Obi. Okay. I think one of y'all asked.
Superhero.
What would your superhero be? What would you be?
If I were a superhero, I'd be racially insensitive man.
Racially insensitive, man.
Oh look, there's Ching Chong Chinaman.
Oh god. You know that one girl from Love Island got like kicked off because she said, was it with the eyes things? She's like, my eyes get a little this. I was like, stop. Sibley, was this you? You asked this one? Yeah, exactly. Yeah.
I can do that because my eyes do look Chinese.
My eyes do look Chinese, right? And then you're like, is it really racist? Because I mean, that's just like how certain people look. Like what? Like chill.
I, like most Asian people, well, other Asian people. Wait, how does that work? I have heavy epithelial folds. Asian people have heavy epithelial folds. That's why our eyes look like that.
Yeah, there is a biological reason.
That's why the English can tell that I'm not English because I don't have their eyes.
Is that why you're Scottish?
It's because the geography is different in Scotland. So it's
okay.
colder. It's colder, more icy.
Yeah.
Sunlight. It's weird angles. Yeah, so
We don't really have sunlight.
I didn't see the sun until I was 10 years old.
Oh my god. You know, it's funny. The further north you get, during certain seasons, the sun actually like stays out forever. Pretty crazy. Like I was in Michigan this weekend, and which is pretty far north. It's almost up by Canada, and sun didn't go down till like 10 p.m. I was like, what?
I was going to say Canada's much further north than even the northernmost point of Scotland.
Yeah, I think it is. Josh says, what levels of homework are you capable of doing? I don't know. Try me, bro. I'm doing college physics now. Math-wise, probably up to like Diffie Q. I could wait for office hours in 2 days, but I can get help. Why not? Yeah, why not? Yeah, submit a question. Okay. C. Okay. And then, okay, so now I need to like worry about what the hell's happening with this one again? Oh, you want to see something cool here? Sib, watch what happens here. How do we submit it? I think it's in a screenshot. I thought I had it pretty well advertised, but it's okay. I should put it in the description, shouldn't I?
What you do is you put down the phone and you use adults' machines, not children's machines like mobile phones.
There you go. You can submit it mobile, but there you go. That's how you do it. That's how you submit a screenshot.
Gay.
I should have that one. Gay.
Okay.
Okay.
I love that.
Yeah, where's that from? Parks and Rec?
No, it was oh dude, I've even forgot the guy's name that says it.
Oh, it's like Seong Young
famous dude as
something.
well.
Yeah, he's on The Hangover. All right, watch this, Sib. Do you see how like this end of this capacitor connects directly with this end of this capacitor? That's like these two. So these are going to connect. Michigan is also on the extreme western end of the time. Oh, that is true. Yeah, you're right. The extreme western end of the Eastern time zone is what it is. Oh wait, yeah, Sib, you can speak. What's up? Oh, is your mic working, Sib?
Doshibashita.
I was going along with what you were saying, but I don't want to get too off topic. I know you have a lot of questions, but
What's up?
those questions. What?
Yeah. What questions? What's up, Sib?
Can you hear me?
Yeah, I can hear you. Yes. I can hear her.
It's a little quiet.
Let me boost her up.
Oh,
Well.
yeah, I'm not sure. I think there's some sort of connectivity issue.
Oh, okay. try here. I'm gonna try putting her off the stage and putting her back on the stage. How do I thought I could move people off the stage. Why can't I do that now? Okay. Try coming back, Sid.
Would you just disconnect her?
Yeah. I didn't disconnect her. I think she disconnected.
Okay. I think there is a lag between you and me as well.
Is there?
Slight.
I think
But
it's
it's-
very... No, I can hear you pretty on point.
Hmm.
Let's see. Sib is back. Test.
Yeah. I hear a little bit of a lag as well.
Okay.
Speak into the microphone.
Let me just wrap this question up. But Sib, you can say anything you want, and I might hear it like 5 seconds later, but I'll respond to it. We can only go so far with technology these days. This is why I do like teaching in person better, but you know, for whatever reason, this is what they wanted. Very cool. I see how this works now for this one. Okay, so maybe this picture will like help people understand. And then
I know you haven't written the test yet, but I was wondering, you know, for those questions that are weighted.
I heard part of it. She said, I haven't written the test yet, true. And then for the questions that are weighted, I want to say she's asking about the questions at the end that are weighted more heavily. I think Sib has a question about that.
Are you hearing that latency sound from Sib? Like
No.
mechanical kind of sound?
It sounded kind of mechanical. Yeah.
Yeah.
Yeah. I think it's probably Sibley's connection. My connection's doing. I'm submitting to like.
Oh, I'm sorry.
You're good.
It probably
It's
was
not your
me.
fault.
Yeah, it's not your fault. It's the internet.
Yeah, it's the internet's fault.
There you go.
I was simply pointing out the issue, not blaming you for anything.
Yeah, we're not blaming you. But okay, so you were asking about the test I haven't written, the questions. Probably, are you asking about the last two, which will be the scaffolding questions?
Oh yeah, like I'm just trying. Like I'm kind of scared. I'm trying to get a sense of like what subject it's gonna be on, or you're not.
Oh.
Are you allowed to like tell?
Yeah, one of them will probably definitely be like an electric, figuring out the electric field at different locations, and then finding out the electric potential at different locations for like a certain shape.
Okay, and then we could use like Gauss's law, right?
Yes, you would have to definitely use Gauss's law. Yeah, Gauss's law would be a good like scaffolding question because there's a bunch of different parts you can go to it. And then the other one, probably something with capacitors. Yeah.
Oh, thank you so much. I appreciate it. I'm also good. I'll probably like tomorrow ask you again for that concentric those shells.
Yes.
Finding the potential for this concentric shells, for some reason it confuses me a little bit.
It's okay. Yeah, I'll go over it. Don't worry.
Okay, thank you.
You're welcome. Yes. Awesome. See, eventually the internet fixes itself. Josh, my boy, dude. Okay, so Josh asked like, how much math can I help with? This I probably can't help
Wait.
with. I can't really do,
Before I look
can't
it
really do
up,
Hilbert spaces. What's up?
before I look it up, Gauss, Friedrich Gauss.
Yeah, is it Friedrich Gauss? I don't know which Gauss it is.
Okay.
Yeah, go look it up.
I was just gonna ask before I look it up.
What class is this for, Josh, dude? What is this? Prove that T is a Hilbert Schmidt. Only yeah, I don't know what this stuff is. This is probably discrete, right? Or is this like? There you go.
Carl Friedrich Gauss.
Bounded operators course. Yeah. Unfortunately, I've never taken nor taught a bounded operators course, but it sounds like some people in the chat may know, so they're free to like, you know. Yeah, Lagrange multipliers. That's also like, it's just slightly outside of. I've done Lagrange multipliers. I have done that. Because that's like a graduate level mechanics class. I just don't teach it. It's takes like a certain level to teach those things. Binding operators. There we go. See? More words that I know what an operator is. I don't know what a binding operator is. Okay, but in this one, this capacitor is basically worthless. Because it's in like parallel with these two things. So whatever the charge is here will be the same as the charge here. So there is no capacitance or voltage difference between these. So this one, I want to say it's 1 over C plus 1 over C to the negative 1 plus 1 over C plus 1 over C to the negative 1. Because it's like these are in series. And then you have two series which are in parallel with each other. So what is that? That's C over 2 plus C over 2 just equals C. Is that right? The answer is just C? Silly. Yeah, the answer is just C. Wow, that's cool. Okay. What's up, Fem? Fem, do you know anything about Hilbert space operator things? This is what someone asked me on my stream. The bridges of a Königsberg problem. Oh, I don't know what that is. Ko says, can you talk on some classical E&M field theory? Not quite. Nope. I never took field theory. You're welcome, Sib. Femvox says, oh good lord, no. Oh, great heavens. We do have some other, I would say higher, so my PhD's in physics, so I only went up to like DiffyQ in math. I didn't do any like gauge theory, I didn't do any field theory, I didn't do any like discrete this, I didn't do whatever magic operator tensor land this thing is. But we do have some other people, other streamers that do like higher level math, or they have PhDs in math, which I'm like, they must be taking it. Yeah, or like topological. I don't know anything. I don't know any topology. I've never taken a topology class. Or umbral calc. Yeah, don't know what that is. I would say like topology is super fun. You should take it. Yeah, maybe in my spare time, but I don't really have much spare time these days. You're trying to derive the Maxwell distribution? I don't know where that is either. Okay, Fedekai, you did give me one. Oh, you gave me like 3. Okay, can you just let me do one of yours. Let me see. Oh, the concentric spheres. Let me do that one tomorrow, cause. Or here, let's do this. Yeah, I think I can do this for you.
Did I skip my question already? Or
No, we haven't gotten to you, Ethan. I'm still helping out at UCLA.
okay.
Am I a teacher? I am. I'm a physics teacher. Yeah. If anyone on the chat wants to help out with high level math, go find each other. Or you can join our Discord and connect with each other if you want. That's really cool. Or, yeah, exchange socials, whatever you guys want. Okay. Let me see. A point charge Q. Yeah, you're good, dude. Appreciate it, Co. Outer radius RE2. What's the electric potential at the center of the small? I'm assuming R is less than R1. Okay, cool. So you got to figure out what E fields are everywhere, right? Okay, cool. So there's Q in here. Conducting shell. Okay, so the first thing you got to do, Fedekai, is you got to figure out where the electric fields are everywhere. So for R is greater than R2. So when you're outside here, anything here looks like a point charge. And so E is the classic. E is equal to, I'm going to use K. KQ over R squared. Okay? And that points in the R hat direction. And then for R1 less than R less than R2, E field is equal to 0. Because there should be no electric field within a conductor. And then for R is less than R1, we should have the same thing, right? E is equal to KQ over R squared. Okay. And then in order to figure out the potential. So let's do change in potential all the way from, we're going to integrate from infinity to R. We have to now break that up into, and this is negative E dot dl. I need to break this up into 3 different things. So I got to go from infinity to R2, right? E dot dl. And then I got to go from R2 to R1. E dot dl. And then I got to go from R1 to R. E dot dl. Okay. This is going to be negative KQ. And then it's 1 over R squared. But integrated, so that's going to become negative 1 over R. From infinity to R2. Here the E field is 0. Because in between R2 and R1, there's no E field. And then here you're going to have minus KQ, another negative 1 over R, and then that's going to be evaluated from R1 to little r. Nice. Okay, cool. So I think I can just pull out the KQ over R. So we got KQ, and then it's going to be 1 over R2 minus 1 over infinity plus 1 over R minus 1 over R1. This goes away. So you get KQ 1 over R2 minus 1 over R1 plus 1 over R. Yeah, and that's the correct answer. Nice.
Oh no.
Okay. Let me know, Fedekai, if that makes sense. Good. How did I find the E field for each region? So these come from Gauss's law. which just says that E times 4 pi r squared is equal to Q enclosed over epsilon naught. So this is equal to 1 over 4 pi epsilon naught Q enclosed over r squared. This is K. So you get KQ over r squared. And the key thing is that wherever you are, okay, since there's only just charge here, oh wait, it said it's located at a distance r. Oh, my bad. Sorry, wait. Oh, interesting. There's actually no charge enclosed once you get inside here. Sorry, I thought the Q was just chilling here. Uh-oh. Yeah, wait, this is actually a little bit trickier. I think when you have a conductor and you have a charge like that, you just put the charge at the center. Yeah, that's right, Sibley. Yeah. I think you assume the voltage is the same as if it were in the center. Why is that? Oh, there's a shielding effect. Yeah, I mean, well, what happens is if you have a bunch of, like, positive charge here, you end up getting, like, more negative charge here and then, like, more positive charge over here. And I think it symmetries out to having the same at the center. There's also the problem of, like, potential has to be independent of path. You guys are still, wow. They have like a monopole theorem for like why this is. Oh. You're not cooked, Mizin.
That's dope.
Mizin, it's okay. Yeah, bro, this is like this is the this is a real pain, really. This is the whole explanation they give me. They start talking about like monopole and dipole moments. So this is what they say. A spherical conductor held at some potential forgets where inside you put the charge when you ask what is the potential at O. Yeah, okay. Oh, one sec, Mizin. Let me give you the permissions. There you go. You can say bad things now. There you go. Yay, good job, Josh and Waifu. I'm glad y'all were able to figure that out in my comment section. That's pretty cool. Yeah, I need a beer after reading that. 100% Mizan. Yeah. Yeah, this is kind of like just whatever. I wonder where in the textbook that comes up though. Yeah, Josh, there are some like real savant young people that are very interested in high level math stuff, and it's cool. I'm glad they find it interesting. I'm trying to find where in the textbook it says that you can say the potential of a conductor is same as putting the charge anywhere on the inside. That never really got covered. That's kind of a little flub there. You're bested by a high school. It's okay, dude. It's okay, bro. Everyone learns at their own pace, you know. Yeah. Okay. Let me see if I got some other questions from the students. 1 sec. 5K's been waiting for a while, or 1K, and then Ethan.
You still have Kudu up?
Yeah,
You have
let
Kudu?
me do your question, Ethan. You're chilling around, and then 1K. I'll do yours if you're here. All right, let's see. Planet X has 2 moons, Alpha and Beta, both orbiting the X in uniform circular motion. The mass and radius are that. Cool. If the mass of moon Alpha is that and its period is that, what is the distance from the center of Alpha X to the center of Planet X? Is this like the two-body problem?
I have no idea. I thought they were wait. You still have Kudu up? You're still using Kudu?
No. Well, I mean, no, I'm not answering too many more. Thanks, Sib. You're good. Is this Kepler's law? It is Kepler's law, right?
Is Kudu like still being used for SCP and stuff?
Yes, we are going to use it later.
Oh, alright.
Not right now.
And
Right. I was doing some stuff on Kudu for my UCLA class. What is Kepler's law for this?
Rather.
Does Kepler's law have to do with the mass?
I just have to ask you.
What do you want to ask me? What's up, dude?
Like comparing questions, is mine like one of the easiest compared to others?
No, this isn't the easiest. I mean, it's definitely easier than this question. I can't even do this one.
No way.
I needed some waifu who's a savant 10th grade math genius to solve it in my comments. So
10th grade math genius?
some of them are, yeah, I mean, I don't know. Everything happens at a different pace for different people. I know some people that went on to become like absolute genius physics people, but they were like pottery people in high school, or like they went to art school and then decided to go do a physics PhD. So I always tell people like don't get like too worried about yourself if someone younger than you is smarter than you in a certain thing. Like Everyone's path is different. It all goes in different ways. As long as you're like going in the path you want and you're making progress. This is simple plug and chug. It is waifu, 100%.
Plug
But
and chug,
even-
wait, what?
Plug and
So-
chug means you like find a formula and you
Oh.
plug in the numbers and you get an answer. That's what he's talking about.
I know I've tried to plug and chug before, but like, which law is this though? Which law is this?
This is Kepler's third law.
Kepler's?
Yeah.
Is this like in high school taught or?
It can get taught in high school. It's probably mainly a college thing, but yeah, it uses mechanics and gravitational attraction forces
Okay.
things
Or
to relate the amount of time and distance and whatever that big celestial planets do to each other. That's the short version of it. Yeah. So, interesting. Do we need to know the mass? I feel like you can just use this. T squared equals a cubed.
how can it simply be expressed as that though? Like, what about the 4 pi cubed over gm?
Yeah, those are different numbers. I forget which m goes where.
It's a solar mass. The mass of the moon alpha is that.
One sec. I think I'm
This
using the
is
wrong. I think I'm using the wrong formula. I think this is for things going around the sun. Sorry. Don't worry about M alpha. What do you mean? Don't worry about it. Is it just because the mass of the planet is so much bigger? Is negligible? You don't even... Okay, cool. All right, so... Yes. Okay, cool. A is also technically the aphelion, though, isn't it? One sec. It's a semi-major axis, yeah. Okay. So I guess we're assuming that it's not like too elliptical of an orbit.
Elliptical?
Yeah, elliptical means it looks like a squished circle.
Well done.
Yeah. R to the third over t squared is constant. Sure. What do the units for that need to be, though? Jeff, right? Because R is measured in meters, T is measured in seconds. Like, what? I don't think that really works. Doesn't matter as long as you're consistent? Excuse me?
Like, oh, there is one question I have about like the office hours itself.
What's up?
Do not mind me going off track here, but like this is the last week I'll be in DOS and I'll actually be free. Next week I'll already be back at work and you will be live streaming during my working hours. So I'm just questioning. It's like I don't think I could be able to ask questions then.
Okay.
I mean, if I were to ask, then I might not even be able to help out any at all.
Yeah, I mean, it's the summer. You don't really need help over the summer, right? Bring up a planet chart and compute it for a few planets, including our own. If you use 1 year and 1 AU. Oh, okay. I see. I see. Okay.
Weekend, right? Like instead of a game for a weekend. Remember?
Yeah, we're gonna do games this weekend. I was out this week. I was out this
What
last
about-
weekend.
And we couldn't even do anything.
I couldn't do anything this last weekend. I was out. Okay.
Mm.
Period is 2 days. I'm gonna do everything in just fucking seconds. Period equals 2 days. So times 86,400 seconds in 1 day. Yeah, we were talking about time zones, Jeff. Okay, cool. So what? That's 172,800 seconds. Okay.
That seems like that's an enormous number.
Yeah.
Seconds.
But then G, I know, is equal to 6.67 times 10 to the minus 11. That's in KGS. And then M is the mass of the planet, not of the moon. So M is equal to 3.2 times 10 to the 25. And then what else do we need? I think that's it. Okay, so cool. So A cubed is equal to GM T squared over 4 pi squared.
That's a T.
Yeah, T is period.
What in the world?
Yeah, this is called astronomy. This is like an
Okay
astronomy.
then.
Okay, so 86,400 times 2 squared times 6.67 e to the negative 11
Each is means 10 to the power
times-
of 11, right?
Yep. Times 3.2 e to the 25. Ooh, spice libraries. That's cool. Divide that by 4 pi squared. So you get a very, very big number.
A huge number then.
That's huge. Let me just make sure I did this right. Yeah, right? This squared is that times 6.67 times 10 to the minus 11. What's up? What's up, Jaden? Times M. Yeah, 3.2 times 10 to the 25 equals that. And then we divide it by... Oh, and then we gotta take the cube root of it. Sorry, because this is r cubed. Okay. And then we do this. Yeah, and then we do this to the 1 over 3. There we go. Oh, okay, cool. So that gets me like 117 with a bunch of zeros on it. Oh, let me divide it by 1,000 for kilometers. Yeah, 117,309.
It should
But
be
yes.
T, right?
Well, the issue is that you need to subtract the radius of planet X, because it says what's the distance from the center of Alpha to the surface of planet X. So when we calculated this being 117,000, what they really want is this. So you have to subtract this radius, which is equal to like 5,000. So it should be just 112,000. Should be answer choice E, actually. And it should have had kilometers on it. Yeah, cool.
Did you want to know what else I have to go?
Good catch on that waifu. What's up, Ethan?
Yeah, if you look at the question, look at how moons is spelled, like at the very beginning.
Moons. Lots of O's. Did you spell
Trios.
Did you write this question?
No, I did not.
Oh,
I
okay.
literally just screenshotted it, and it had 3 O's in that question.
That's pretty funny.
Is that to go?
Nice. What's going on with chess, dude? You said something was going on with chess.
This week.
What?
Alright, sorry. I was asking something. Alright. I was about the SC. What are we winning again? Okay.
Nintendo Switch.
Oh, for real? Number 2 or 1?
The newest one. Yo, what's up,
Okay.
1K?
I mean, I did get to try a little bit of it with Mario Kart World, but it was only a demo and just to try it out on display.
Nice.
All right, and the question was like, what game are we playing this week?
I think Roblox.
Saturday. It's on Saturdays, right? Saturdays at like 5 or 6 p.m. You said?
Should be on Saturday.
Okay. On Saturday, I'll be leaving Denver by 10 p.m. and I think like my flight is 4 or 5 hours long,
Okay.
so I should still be able to make it. To the
It'll be
game,
early. It'll be early.
about-
It'll be early Saturday. Yeah, you'll be fine.
Wait, no, wait. What do you mean early Saturday?
Like in the afternoon. You said you're not leaving till 10. Oh, you talking about
I'm
10
leaving-
a.m.?
I'm not leaving. 10 a.m. Yeah, 10 a.m.
Oh. Then yeah, it'll work out because you're on Denver time too. That makes sense.
Oh wait, so I think Denver time is the same as Belize time right now. I think
Yeah,
they're both the
but
same time.
it's 2 hours for me.
So 2 hours later than you.
Mm-hmm.
I might still be able to make it.
I think you will. We'll see. Here, let me get these real quick.
Hopefully.
1K. What's up? What do you need help with this one?
But I have to go
Restriction-
ahead. Thanks, Adago.
Yeah, you're welcome, dude. Oh, it's 1, not 2. Jeff with the time zones, dude. I can always trust you to have the time zones down, dude. You need help with the holes? Okay. So holes occur anywhere you have something that would divide by 0, but it gets canceled out on the top. So in this case, the hole is at x equals 1. Because that would cause this to divide by 0. But you cancel it out with the factor on the top as well. So that's a removable discontinuity. And then to figure out where the hole is, so you get rid of this, and then you plug in x equals 1. So at x equals 1, f of 1 is equal to, that's 1 plus 2 over 1 minus 3. So this ends up being 3 over negative 2, so you get negative 3 halves. So the hole is at 1 comma negative 3 halves. How would you show your work for this? Okay. To show your work, I would cancel this out. I would show that this cancels with this, okay? Well, first, the restrictions on the domain, right? Right away, you can just say, well, x cannot equal 1 and x cannot equal 3. Because that would cause the denominator to be 0. But then if you show that these two things cancel, then all you have to do is plug in the removable discontinuity, or the hole, in for x, and evaluate, and you should get to this. So then when dealing with vertical asymptotes, usually you'd have vertical asymptotes at x equals 1 and x equals 3, but because the x equals 1 got taken out as a whole, now you only have x is equal to 3 as a vertical asymptote. Intercepts, I don't know, x equals negative 2 is 1. And I don't know if there is a y-intercept. Wait, yeah, there is. You just plug in 0. Duh. Yeah. And then y equals negative 2/3. Those are the x and y-intercept things. And then the end behavior. As x approaches infinity, you're just going to get 1. So you say just y equals 1. What are they feeding these kids these days? I guarantee you, Josh, waifu is not the typical kid. I'm just gonna say it straight up. He is not. Most of the kids are getting fed like terrible brain rot on TikTok. I see it. I work with a lot of it. Waifu is 100% a outlier, is what I would say. What's good to be an outlier in this case. But also, it is super fascinating because younger generations now have access to so much more information. Like, if you really wanted to go learn, I don't know, QFT or GR, like, on your own, you probably could do it as a high school student because you have access to so many videos, tutorials, animations. There's so much on YouTube now these days that I'm sure you could get someone to explain it to you in a way that makes sense. Back in my day, you had to, like, go find a fucking book. And those books usually aren't very friendly towards 10th graders. I'm glad you like the brain rot as well. Yeah. But yeah, it's cool. With like the infinite, you know, potential also comes like the infinite, you could just like not do anything. Like, kids will still just be kids. Intelligence and humor are unrelated, for sure. I mean, sometimes they're related. Depends what type of humor we're talking about. Like, there's definitely unintelligent humor. And there is also, on the converse side, like, very, like, super brainy, intelligent humor. Yeah, see, waifu, yeah. Even when I was in, like, grad school, and we still kind of had YouTube, but there weren't as many, like, influencers or creators really out. I kind of had to really just, like, rely on, like, either learning from my fellow friends, like my fellow students, or, yeah, just trying to sludge through Griffiths or Jackson. Like, one of those textbooks which is just fucking awful. Or, yes, even, dude, that's the most recent thing, which I have found invaluable for myself, even from a teaching perspective, because, again, I don't remember everything. You know, I teach such a wide spectrum of all STEM courses that sometimes, you know, a question will come up and be like, ah, shit, I forget how this works. But if I just ask AI, I can instantly, it comes back in a second. And I'm like, oh, wow, that's so nice. Rather than me have to, like, go through finding the textbook, going to find the example, blah, blah, blah. You can ask AI to just do it. And then if I don't understand, like, one of the in-between steps, I'm like, yo, explain that. And it's like, oh, it's this little trick. And I'm like, okay, cool. Wow. This is super useful. Yeah. It's a blessing and a curse. I think the issue with it being the curse is that now you can be tempted with the easy way out of just copy pasting everything and, like, never actually learning. Because if the only way for us to, you know, keep a metric of are you learning things is for students to complete assignments, then the temptation becomes to just get the assignment over with and just copy paste AI and not actually learn what you're supposed to be learning. So, I don't know. There's some, again, rarer cases like you, waifu, where, like, someone actually wants to learn this material that's difficult and they're excited about it, and that's super awesome. I love that. And in that case, AI is the best thing ever. Because you get, like, basically a personal tutor. I think this is what I was trying to explain to Aleph when he was like, how much money can I make tutoring, like, online? And I was like, I don't know if you can make any money tutoring online anymore. Because anyone who really needs a tutor could just get ChatGPT to explain it to them. What you need a tutor for is kind of almost like I say it's a psychiatric, or, like, you need, like, a human for accountability, and for you to feel like, I don't know, you want to impress, I guess, maybe, or like you don't want to look stupid. Like you don't care if you look stupid in front of AI, who cares? But if you're like working with another human and the human's asking you questions, you're probably more likely to invest in, I want to make sure I'm saying the right thing, versus, I don't know, if you're kind of just like passively learning on your own, you don't really care whether you're right or wrong, then like there's no real accountability on it. So yeah, in that case, like tutors get hired off of personality. They don't really get hired off intelligence at that point. I'm nowhere close to being one of the smartest math or physics people. I'm not, but I have a way with people and talking to people, and especially talking to people about things they don't want to learn because it's complicated and hard, and getting them to kind of see like, hey, it's not that bad, man. Like, you know, it's okay. All right, Nick, you still around, Nick? We've been going for what, 2 hours and 15 minutes? Where's Nick? Nick is my like cool down. So earlier I was like kind of hurting my brain with harder E&M stuff, and then we start moving towards, you know, kind of some easier like Kepler laws. And then finally, yeah, I love this. This is my favorite. This is just nice, easy breezy, like pre-calc. This is probably algebra. And then for the last bit of the evening here, we'll have Nick with his court officer questions. So learning happens at all levels. What's up, Nick? You want to come on stage?
Yo.
How was your weekend?
Good.
Nice.
What about you?
Busy. Again, I flew in this morning, so I'm like, I'm so tired.
From where?
Chicago. I flew in from Chicago.
What did you do there?
It was my friend's like bachelor party. It's like my sister's fiance. Like had like a bachelor thing up in like Michigan. It was a lot of like driving and stuff. Yeah.
Sounds fun.
It was. I mean, yeah, it was fun. I'm just exhausted. I'm just tired. And on top of this, dude, like teaching every single day at UCLA is fucking draining, dude. I'm not doing this another summer. I'm glad I could try it once, but like, bro, I no, dude. This eats, dude. This starts beating the fun out of teaching pretty quick. Yeah.
How many kids per class?
How many kids per class? In my class, like 110.
Oh shit.
Yeah.
So it's like a big auditorium type thingy.
Yeah, but it's online, so it's literally just on. But yeah, when I teach in person, yeah, that's 180 kids in like an auditorium. Yeah, that's a big one.
Damn.
But yeah, I mean that's a little bit more. It's like person to
Do they all
person.
pay you, or half of them are on the phone or something?
You can't really tell. I can't tell if it's online, but in person, I don't know. I'd say most of them like kind of pay attention. Waifu says that this question, what you're doing right now, is what I'm doing in high school right now. I think he's talking about this. Yeah. Yeah. Keep it up, waifu. Don't let the seemingly easy things that you're doing in school deter you from to keep pursuing like really advanced stuff in math and physics. Like that's a cool and unique thing you have. So yeah, don't give up on it. Just wait till you get to college, then you can go take whatever like high level courses in things, and you'll find like a mentor who can like point you in the right direction. Okay. All right, let's just do these 3, Nick, and then I'm tired. I'm going to bed. Actually, I wish I was. I have 2 kids with fucking tests tomorrow that I have to teach. Ugh.
Damn.
Yeah, okay. On a rainy day, a senior officer found that 9 of his 50 officers reported to work. What percentage of his officers were absent? That's kind of funny. How do you think you do this one? 13.
Divide 50 by 9.
To divide 50 by 9, not quite. Aleph says, Nick, I have a book for this. Do you want it? Yeah, sure. What's the book, Aleph? You have a book for like court officer stuff, do you? You got a PDF somewhere? Okay, so here's the key thing here, Nick. Percentage is always equal to part divided by whole. Okay? Okay. So it said that 9 of his 50 reported to work. Okay? So how many officers did not report to work if 9 out of the 50 did report to work?
So it's 9 divided by 50?
So 9 divided by 50 reported to work, right? 9 over 50, like we'll say, like went to work. How many out of 50 did not go to work?
41.
Good. So 41 out of 50 were absent. Okay. And then they want this as a percentage, right? So this is just 41 over 50. Which is just going to be 78. No, 82. 82. It's 0.82. But then this is 82%. Cool.
So 82% absent.
Yeah, 82. Yeah. So you could have found the percentage that weren't absent, right? That would have been 9 out of 50. So 9 out of 50 is the same thing as 18%.
Okay.
And that's 18% are not absent. And then you need 100%, right? So 100 minus 18 is 82.
Right.
Okay. All right, let's get the next one. Here, I'm going to save this. Okay, Officer A and Officer B work at the same post on the same days, but their hours are different. A comes in at 9 a.m. and leaves at 5. 9 to 5, boy. Okay, fine. So A goes from 9 a.m. to 5 p.m. Notice what I'm doing, Nick. It's always good to just like try to summarize what's in the text as like quick little things down here.
Yep.
And then we say like, oh, but there's a lunch from 12:15 to 1:15. Okay. Officer B comes into work at 10:50. What a weird time.
Yeah.
And works until 6:50. And he has lunch between 3 and 4. What is the total amount of time between 9 a.m. and 6:50 p.m. that only one officer will be on duty? Oh, that's kind of cool.
Yeah, this was interesting. So first is the 2 lunches, so that's 2 hours.
Good. Yes. So during 2 of the lunches, you're right. Only one officer will be there, right? Okay, cool. I like that. You could draw a number line. You could. Luckily, the lunches don't like smack with any of these things or something, or like they aren't outside the times. Okay, but then also, right? Officer A gets there earlier than Officer B, right? So he's the only person there. So how much time is he there for that the other guy isn't?
An hour and 50 minutes.
Good, hour 50 minutes. Nice. Yeah, from 9 to 10:50, right? And then the same thing here, right? This guy is there after 5 p.m. until 6:50, so that's another hour and 50 minutes. Okay, so then the total time, right? You have 1, 2, 3, 4, so it's at least 4 hours. And then it's 50 minutes, 50 minutes. So I like right there. I say 4 hours, 100 minutes. And then 100 minutes can be broken up into 60 minutes, which is 1 hour, and then 40 minutes.
So 5 hours and 40 minutes.
Nice. 5 hours, 40 minutes.
40 minutes.
You could have also drawn a cute little number line if you wanted to.
How would that work?
Well, okay, so you know, at 9, and then what do we got? We got like 5, right?
Uh-huh.
So this is Officer A. And then he had brunch or whatever the fuck between 12:15 and like 11:15, like that.
Hmm.
$12:15 and 1:15. And then you looked at Officer B, right? Well, he did this. Officer B started later but ends later, right? So this was from 10:50 to 6:50. But then he has lunch between 3 and 4.
That's cool.
So that's like between here, right?
Mhm.
So you can see there's a couple gaps, right? Where there's only one person, right? There's this, there's this, there's this, and then there's this.
Mhm.
Yeah. So this is 1 hour 50. This is 1 hour, 1 hour, 1 hour 50.
That's cool.
Cool. Yeah, that's a pretty one. Thanks for the suggestion, Jeff.
Your drawings have become better.
Yes. Yeah, I think that's a better drawing. All right, and then we'll do one more. Ooh, okay. An officer's log recorded the following attendance of 30 officers. Wow. On average, how many men were present on the weekdays, Monday through Friday? So I think you just add these, right?
I think
There's a high absentee rate on the weekends. Right? So to find average, you just add up what there are, divide by how many things you had. So that's gonna be divided by what?
5.
Good. Divide by 5. So it's 48, 78, 99, 115. Divided by 5. 23.
Nice.
Nice. Not too bad. Good job.
Thank you.
Well done! Well done!
Thanks.
You're welcome, Nick.
I guess I'll be getting off. Probably
Yeah.
will go back to Twitch.
Yeah, you're all good. I'm gonna end the stream soon. I'm pretty tired. And I still got 2 more hours of teaching. Probably more. Okay, cool. Alright, let's end the stream. Thank you, Aleph. Appreciate it. Coin system? Oh, you can get prizes for asking questions in the stream. Yeah. Nick, you can show it to him. Anyways, yeah. Thanks everyone for coming. Appreciate it. Thanks for all the questions. We'll have office hours again tomorrow. Starting at 4 p.m. Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. If you're ever wondering when we stream, we have a calendar. There's the calendar there. And then I'll dump the calendar in. Oh, not here. Where is it? This is it. So, yeah. Feel free. Check out when we're streaming. And we have other friends that stream. We got Nick. Not Nick, sorry. We got Zach. Penn Center, I think, is still doing stuff. Yeah. There you go. Yeah, Zach's got a stream Wednesday morning. That would be who, if you want to ask some high-level math stuff, Zach is a really good guy to talk to about that. That or Penn Center. These are both PhD math people. So you're very welcome, Doctor. Okay, let me go raid another channel. Let's go show some love to someone else on Twitch. One of our other friends. Who do we got? Math time. Who is this? Is this person actually doing math? Maybe not. I don't see much math on this person. Whatever. I guess it sounds like math. So, go raid. Say hi to him. Okay. That's Alejandro. He's probably cool. Yeah. I should subscribe to him here. I'm gonna go. We'll go raid him. All right. We'll see you tomorrow. Peace.